All right, we're going to take a look at dividing polynomials in section 5.2. Let's start with this one. All right, and this type of division problem is not the most typical that we're going to see in this section. But what we're dividing by is just one single term. There's a lot of factors in there, but one single term. And so what I can do is I can think of this as actually several different division problems. We can divide the first term by that, then minus the second term is divided by it. Then the third term. So we can simplify each one of these fractions separately. Thinking back to what we did in class on Thursday. On the first fraction, 20 and 4 can simplify to 5 and 1. We can eliminate a c from the denominator, leaving c to the third in the numerator. We can eliminate a d from the denominator, leaving a d in the numerator. And we can eliminate an f from both the numerator and denominator, so there's no f there. So in total, that becomes 5 c to the third d. Then minus over here, 16 and 4 will simplify. Eliminate a c, eliminate a d, eliminate a f, so there's one f in the numerator, so minus 4f. Plus, here 4 eliminates, c eliminates, d eliminates, and f eliminates. So there's nothing left. It is a 1. That means the numerator and denominator are the same thing. When you divide something by itself, you are left with 1, not a 0, please. Next, we'll divide by a binomial. And so we're going to use long division. So going clear back to like 4th grade math. Oops. We're going to divide that out long division. We're dividing by x minus 3. So that will go outside. And inside x squared plus 7x minus 30. Very important that these are in descending order and that we're not missing any terms. So if I start with x squared, after x squared I expect to see x, and then I expect to see a constant. I have that. In the cases where something's missing, we'll have to address for that. Then what you do is you consider your first term in your divisor and your first term in your dividend. What do we have to multiply x by to get x squared? Well, you have to multiply it by x. So that's what I'll put up above, lining up with the x term. And then we would take that x and multiply it by x minus 3. So x times x is x squared. X times negative 3 is negative 3x. So that's what I get when I distribute the x throughout. And then I have to take and I have to subtract that from what we had above it. So x squared minus x squared becomes a 0. It eliminates. That was the goal. And then 7x minus a negative 3x. Minus negative, that's like plus. So 7 plus 3x is 10x. Write that down below, and then drop down any remaining terms. And now we repeat the process. So we're trying to say, well, what do we have to multiply x by to get the first term, the 10x? Well, I have to multiply it by 10. So that's a positive 10 I put up above the constant. And then take 10 and multiply it throughout. 10 times x minus 3. Well, that's 10x minus 30. And then I have to subtract that from what I have above. 10x minus 10x goes away. Negative 30 minus a negative 30, that's like negative 30 plus 30, it becomes a 0, meaning there is no remainder. So the answer to the problem was what we had up above the division sign there, x plus 10. Now that was not too bad of a long division problem. But there is a shortcut to some of our long division problems. So that there was called long division. So I want to show you the same problem using what we call synthetic division. Synthetic division is a really nice time saver. It might take a little bit to understand how to write it, but then you can do the calculations really quickly. We can't do it on every division problem though, but when we can, it sure is handy. Here's what you have to do. Take the thing you're dividing, the x squared plus 7x minus 30. Think about the coefficients. So the first coefficient was a 1, and then a 7, and then a negative 30. And I wasn't missing any of the terms, but we're just going to write those down and leave a little bit of space in between them. If it's negative, make sure you indicate that. So I can drop off the variables. And then kind of in front of that, I'm going to make a little half box here. In that little half box, we're going to put the 0. So x minus 3 was what we were dividing by. That's the factor. If you took that and set it equal to 0, like we did when we had factors in chapter 4, we would have had that x equals 3. So x minus 3 was the factor, positive 3 was the 0. That 0, that solution, that's what I'm going to put in the half box. So I actually changed sign. Then to set this up, I'm going to leave as kind of a space, a line, below the 1, the 7, and the negative 30, because I need some room there. And then I put that horizontal bar. And then I like to, before the negative 30, come down below the bar and just drop a little vertical bar there to separate. And that's really going to show us what a remainder is eventually. But here's the process for synthetic division. So I wrote my coefficients, and I'm dividing by x minus 3, so I put positive 3 here. You're going to take the first number, first coefficient, and you're just going to drop it straight down below the line. So I would write 1 there. As soon as you get a number below the line, you have to multiply that number by the number in your half box. So 1 times 3 is 3, and you'll write that underneath the next number. And so now those get added. You will add the 7 and the 3. 7 plus 3 is 10. Write that down below. And now it just becomes a repeating problem, although this one's almost finished. But I would just put a number underneath that horizontal bar, so multiply it by the 3. 3 times 10 is 30. I write that over here, and then you add those together. And I get a remainder, it turns out, of 0. So I see the numbers. The numbers for my answer are right here. But we have to figure out what to put with the 1, what to put with the 10, with the 0. So if you think back to the original problem, it started with x squared. And really what I did is I just divided by an x. I know there's some other numbers involved, but if you took x squared and divided it by x, you would get x. That's exactly what this 1 is representing, 1x. And then it descends from there. After x would be our constant, and it's positive, so that's a positive 10. And then my remainder is 0. Since it's a 0, I just ignore it. So I get 1x plus 10, or just x plus 10, which is the answer I already had. We'll get a chance to see. Let's actually do another synthetic division right now, just for a little bit more practice on what in the world's going on there. Let's try 6b to the 4th minus 8b to the 3rd plus 12b minus 14. So this is a little bit longer synthetic division problem. That's good because it'll give us a little bit more practice, maybe a little better understanding. Oops. Okay, here we go. Forgot a T in there. Okay, so we're going to use synthetic division. So once again, write down the coefficients. 6, -8. And then we have a problem. Watch the exponents. 4, 3. Next, I would have expected a b to the second, and I don't see one. So what's happened right here, I skipped it, but there was a 0 b squared. There wasn't any, so we know that's a 0. That means the coefficient is 0. I have to include that in my list of coefficients. So let's continue. See, so 4, 3, 2, 1. That's what b is. Okay, so I have that one, so it's a positive 12. And then my constant is last, -14. So 6, -8, 0, 12, -14. Those are my coefficients. In the half box, consider what you're dividing by. Be -2, switch that to a positive 2. That's going to go there. And now, a little room, but horizontal bar, and drop a little vertical bar before the -14. Drop the first number straight down, 6. As soon as you get a number below the line, multiply it by the number in your half box. 6 times 2 is 12. So you'd write that under the next number, and then you add them. -8 plus 12 is 4. We got a number below the line, so we do it again. 4 gets multiplied by the number in the half box. 4 times 2 is 8. Write it here under the 0. Very important that we have the 0 and that we didn't skip it. If you skipped it, everything from here on out will be wrong. Because I should have 0 plus 8, which is 8. And then we got a number below the line. So once again, multiply by the number in the half box. 8 times 2 is 16. Add it to the 12, and I get 28. Multiply that by 2, I get 56. Combine that with the -14, and I get 42. Okay, so I have all the coefficients of my answer. And so 6 what? Well, we started with b to the 4th, but I descend 1 degree, or I lose one number for the exponent. So instead of starting with b to the 4th, this is going to be b to the 3rd, and then you work your way down from there. So then b to the 2nd, and then b, and then we have our constant, and then we have a remainder. So let's write the answer down, 6 b to the 3rd, and then it's a positive 4, so plus 4 b to the 2nd, plus 8b, plus 28, and then my remainder is this 42, so we're going to write a remainder in this way. So plus a fraction, 42 is the remainder that goes in the numerator. And then what was I dividing by? Not 2, but I'm actually dividing by b minus 2. That's what goes in the denominator. So there's another example of using synthetic division. Now, synthetic division works very nicely when you're dividing by something in this form. And what's this form? Well, it's linear, and there's no coefficient in front of, in this case it was b, but oftentimes we use the letter x. But x minus 3, b minus 2, could be x plus 5, x plus 17, x minus 1. As long as there's no coefficient in front, we can easily use synthetic division. Let's take a look at this next problem. It's a division problem, and we are dividing by something linear, but there is a coefficient in front of the x. We're divided by a 2x plus 1, making it not nearly as nice of a synthetic division problem. it is possible to do it, but we end up with fractions the whole way through, and we have to kind of learn how to do it. If you look through your textbook, it does walk you through the process of doing it. And you can learn, it's not that bad to do. But what I'm going to propose is that we don't bother trying to learn that. Let's just use our long division. That's what I'm going to promote. And so we're dividing by 2x plus 1. 8x to the fourth. Watch your exponents. So it was a 4. Next, I would expect a 3. There is none. Notice it skips to 2. So think of it as 0x to the third there. After 3 comes 2. I do have that. It's a negative 4x squared. After that, I would expect x to the first, which I do have, so plus x. And then my constant, which I do have, is 4. So look at your first term, 2x, compare it to the first term here, 8x to the fourth. Figure out what you have to multiply it by. To get from 2 to 8, I have to multiply by 4. And to get from x to the fourth, I need to multiply by x to the third. So in total, I multiply by 4x to the third. So multiply 4x to the third to the entire 2x plus 1, giving me 8x to the fourth plus 4x cubed. So now I subtract that. Those go away. 0 minus 4x cubed is negative 4x cubed. Then go ahead and drop down all of the terms. And now just repeat that process. What do I multiply 2x by to get? Negative 4x to the third. Well, a negative 2x squared. Distribute it. Negative 4x to the third minus 2x squared. I will be subtracting that. Those terms cancel. Negative 4x squared minus negative 2, that's like plus 2. Negative 4 plus 2 is negative 2. I get negative 2x squared, but drop the remaining terms. And repeat the process. What do I multiply 2x by to get negative 2x squared? Well, I need a negative and another x. Negative x times 2x plus 1. Negative 2x squared minus x. Subtract that. Those go away. X minus negative x. This is a 2x plus 4. Yet again, can I multiply 2x by something to get 2x? Yes, just a 1. Multiply by 1. 2x plus 1 times 1 is 2x plus 1. I subtract. Those go away. 4 minus 1 is 3. I now have a degree that's smaller than the 2x plus 1. This is a degree of 0. That was a degree of 1, so it's smaller. I can't do anything else. That means the 3 is my remainder. So my answer had the 4x cubed minus 2x squared minus x plus 1, and then my remainder was 3, so 3 over what we divided by, 2x plus 1. Once again, that could have been done doing long division, but not by putting a negative 1 in the half box. You'd have to deal with the 2 first, you get a fraction, becomes a little more complicated because then you have to adjust for that at the end. I think that this type of problem is better off just using long division. There are a couple problems on your assignment. I don't have the assignment number written in front of me right now, but I want to say it was maybe questions 27 and 28 where you're dividing by something with a coefficient like this. And on the calendar, we just said use long division. So I would encourage you to do that. Thanks for watching.